All right, now that we have an idea of what we're doing, let's take a look at what is going to happen when we convert things to CMYK. We're going to do this a few times though, so boop, boop, boop. I'm going to go ahead and open up the history state, roll on the history palette window here, whatever, roll on down to create new document from current state. That's what I'm after inside the history. So these used to be called palettes, but now they seem to be referred to as windows. I'm going to keep calling them palettes, but however you want to say it's probably fine. All right, let's convert these to CMYK using, actually let's do one extra one, using our newfound knowledge. So I'm going to go to edit and convert to profile, and I'm going to use perceptual. And I'm going to go to edit, and I'm going to do a do a convert to profile, and using saturation. And I'm going to go to edit, and I'm going to convert to profile. Guess where I'm going with this? Using relative. And I'm going to go to edit and convert to profile, and this time using absolute. And let's take a look at how these change. So keep in mind, we have our original vibrant snail. This is what it looked like. I should have named each of these. So with movie magic, I will. So here we have the perceptual. Again, the vibrant, perceptual, saturation as compared to the vibrant. The relative as compared to vibrant. The absolute as compared to vibrant. So here is the relative colorimetric as compared to the absolute. And you can see how on the absolute, we lost a lot of details inside the darks. It just vanished. Whereas the relative, we did not. Now here's the saturation, and you can see what I was saying about the saturation causing sort of a desaturated effect in the greens. They became flatter. They lost some of the almost roundness that they had, I guess the curvature that it used to have, but really it's just the lack of the dynamic range now. As compared to perceptual, and here's absolute and perceptual and relative and perceptual. Usually relative or perceptual are going to be the ones that you'll be using. They tend to work the best, and you'll know that they are fairly similar. They work the best because they're catering to human eyes as compared to the rest, which are more or less mathematically fixing things. It's just taking care of it. So I'm going to say I'm digging the relative colorimetric as compared to the perceptual just a little bit better. Well, yeah, I'm going to stick with the relative. Now, again, the relative didn't move anything around. It didn't have to move, whereas the perceptual did move everything. So it is less, I'd say it's less like the original. Well, they all are, but it left alone what it could leave alone. Whereas the perceptual, everything changes. It just becomes duller everywhere. I'd like to keep as much as I can, so I'm going to do that on the relative. So why did I make a fifth one? Well, I say relative worked best for this image, so let's apply it one more time with an edit, convert to profile, and this time when we do the relative colorimetric, we're going to take off the black point compression. So here's a relative colorimetric, I think I typed that right, without the black point compression. Did I say that right? Was that black point compression, or did they call it? No, compensation. Sorry, black point compensation, not compression. All right, and so now we can compare those to each other fairly easily. I'm just going to right click on this guy, and I'm going to duplicate him over with the duplicate layer, perceptual, to the last one there, which I think is like duplicate state. And here we go. So now we have two. Oh, I needed relative, not perceptual, my bad. Relative colorimetric. Duplicate layer. Okay, right click right on it. Duplicate layer. Bump it over to the last one. All right, so without the black point compensation with it. So you notice that without the black point compensation, we get much more vibrant dark, but we've lost all the detail. And with the compensation, it's not as dark, but it maintained the detail in it. So that's another choice you're going to have to make. I personally prefer having it with the black point compensation, because notice that you have, blacks inside of other colors, and so you get to keep those colors a little more vibrant in a lot of cases. Well, in some, you got to make a judgment call on these things. So there you have it. That's how you apply the different intents using your color profile. All right, so that's how you convert from RGB to CMYK. Now we covered all of that so that we can actually get down to what we're going to be doing for this assignment. So tune in on the next video when we actually cover that. See you in a minute. One last thing though. I'm back at the Vibrant Snail, which is in its RGB mode, but over here I have a collection of all of our different tests in a CMYK. If I were to right click on this RGB snail, and actually this is an sRGB snail. If I were to right click on this one and duplicate the layer, toss it right into the CMYK, what is it going to use? Well, if I bounce it over, I can see I have my RGB snail, and it's identical to relative colorimetric with the black point compensation on. So in case you got curious which one the default is, now you know. So anytime you drag an RGB into your RGB image anytime you drag an RGB image into a CMYK file, it's going to use the default, which in my case is relative colorimetric. This is generally the case too. You may have a slightly different setup if you've changed some defaults, or if Adobe changes something in the next couple of updates. But just to let you know, it's going to make a decision for you. So it's always good. It's always a good idea to make that decision in advance, control it, decide for yourself, and then copy it over. Okay, now I'll see you in the next video.